if we have 3D crystal, okay, so in 3D we have seen that our density of say g omega is proportional to omega square, okay, and we also seen our total energy which is proportional to temperature T4, and we seen at low temperature, these are at low temperature, okay, low temperature CV is proportional to T cube, okay. High temperature, it's understood that it follows Dulong-Patent law, and a specific heat solid is constant, okay, 3R. So this is for 3D case we have seen. Similarly for 2D case we have seen G W is proportional to W, U and the total energy proportional to T cube, and CV is at low temperature is proportional to CT square. And for 1D case, G W is proportional to omega power 0, okay, constant, L upon pi, U was T square, and CV was T, okay. But these things are valid, okay, only when, okay, when you have omega is proportional to K, okay. These type of relations are valid, okay, when omega is proportional to K. So when we are using this lattice vibration, we assume that V naught is equal to V naught K, where velocity of sound we have taken constant, okay. So these type of relations are valid when only you have linear dispersion relation omega K, okay. Now suppose you have, instead of having this linear relation, you have this kind of relations, okay, a power ks, okay, whereas can be anything, okay, it can be square, 2 3 1 0 constant, okay. In those conditions these relations will change, okay. So we will not derive the expression, okay, we will just, because suppose when we have calculated density of state, that time we have taken 3D space like a sphere, 2D we have taken circle, and 1D we have taken line, okay. Now suppose space is space, your space is d-dimensional, okay, then we have to take d-dimensional sphere, okay. So that's those calculation I'm not going to do, okay. I'm just giving you formula so that you can easily, without solving also, if they are asking some proportional, okay, proportional type of questions, so you can easily solve, okay. Now let us solve for this, for when this general, when dimensions are d, okay, when dimension is d instead of 2d 3d, dimension is d, and this relation b is omega is proportional to k power s, okay. So let us start. Now suppose for 1D we know, okay, in 1D case we know our gk, okay, our gk is what, gk we know L upon 2 pi, L upon pi, okay, L upon pi dk, okay, am I right? This is 1D, okay.
Yes.
Okay, but now what, instead of we are having relation v naught k, now we have relation a k power a ks, okay. So just put the values here, okay. So we, what will be d omega, if I want to write d omega, d omega will be s a k s minus 1, okay. And again if I write s a, okay, k value, so k value will be what, omega upon a, this will give you what, k value omega by a 1 by s, okay. So this will give me s minus 1 s, okay. So now instead of gk, if I want to write g omega, okay, so g omega will be what, okay. If I solve this one, this will give me s a omega a, okay, 1 minus 1 by s, okay. So g omega will be L upon pi d omega, okay. And if I put the value of d omega, L upon pi, okay, d omega is nothing, s a, okay, omega by a 1 minus 1 by s. Am I writing correctly
Yes, sir.
or some mistake is there?
No, sir.
Okay, so this is omega is equal to k is equal to omega by a 1 by s. Okay, d omega is equal to this one, d omega by dk. This will be dk na. So if I
तो DK की वैल्यू डालेंगे तो ऑपोजिट आ जाएगा.
opposite आएगा ना, वही तो that's why I'm asking. Okay, I'm writing dk. Okay, so you want dk value. dk value will be 1 upon s 1 upon a. Okay, and this was equal to what? S a omega by a. Okay, s minus 1 s. Okay, this was your dk. Now dk will be 1 by s 1 by a. Okay, and this become opposite, so 1 by, so this will become what? S omega by a. Okay, can I write like this? S minus 1 ऐसे लिख सकते हैं क्या? So if you take or this will go bottom, so if you take minus, so I'll take e. Okay, minus s minus 1 s d omega. Okay, so this will become. Okay, now put the values here in this expression, dk value. So my gk will be L upon pi 1 upon s 1 upon a. Okay, omega a. Okay, so you have, if one this become 1, so 1, and this becomes so 1 by s minus 1. Okay, and d omega. Okay, and then these are the constant. I don't need constant. Okay, I need only what? I need only this omega. Okay, so my g omega, now it becomes g omega d omega. Okay, g omega d omega, and g omega is proportional to, okay, omega power 1 by s minus 1. Okay, now you can check.
Sir,
Huh.
I have one doubt. Sir, in this d omega, why have written k s minus 1?
Which one?
This side.
This
d
one.
omega. No, sir, right hand side.
This one,
Sorry,
huh? You're differentiating, na? D omega by dk. You're doing d omega by dk. So this becomes sa. Okay, we have relation and we want to change this k into omega, na. Okay, so now it's a 1d. Now you can check if s equal to 1, then omega power should be 0. Okay, so this is the correct expression. Okay, so this is for 1d. Okay, now same we do for 2d. Okay, in 2d case we have, instead of l square we have a l square. What is the relation for 2d? Anyone?
L by 2 pi square k.
Is that correct answer? Correct expression for 2d? Okay, let me check for 2d. Yes, it is correct. Okay, l upon l square by 2.
फैक्टर ऐड करना होगा ना सर 2.
नहीं, वो अभी फैक्टर अभी हम ऐड नहीं कर रहे हैं, हमको तो खाली प्रोपोर्शनल रिलेशन चाहिए, ओमेगा में रिलेशन चाहिए. ओके, कांस्टेंट का हमको मतलब नहीं अभी. ओके, नाउ ऑलरेडी वी हैव कैलकुलेटेड डीके वैल्यू, ऑलरेडी वी हैव. ओके, and k value already we have. Put this in relation and let me know what is g omega d omega. So g omega d omega will be l square upon 2 pi. Okay, k value is what? Omega by a 1 power s, and dk value already we have. This is 1 upon s 1 upon a. Okay, and omega power a is what? Okay, this is 1 upon s minus 1. Okay, now this 1 upon s this becomes 2 upon s. Okay, so I can simply write g omega is proportional to what? 2 power s minus 1. Okay, 2 power s minus 1. Now you can check for s equal to 1. If you put s equal to 1 here, you get omega. So g omega should be proportional to omega, what we written in the beginning. This is correct expression. Okay. And similarly, if I write for 3D, okay, if I write for 3D, this will give me what? V upon 2 pi square k square dk. Am I correct? Okay.
Yes.
And if you similarly solve this one, okay, if you similarly solve for this, for g omega d omega, okay, so you'll get v upon 2 pi square, okay, k square means omega power a power 2 by s, and dk is again same, 1 by s 1 by a omega by a. Okay, this is your nothing 1 upon s minus 1. Okay, so again this become 3 power 3 by omega power 3 by s. Okay, so now again we have g omega d omega proportion, or g omega proportional to, okay, here we have d omega, g omega proportional to omega power 3 by s minus 1. Okay, now you can again check putting s equal to 1. Okay, if you put s equal to 1, you get omega square. Okay, so this is the, so now you see how I am varying dimensions. Okay, 1D 2D 3D. So this number is keep on increasing. For 2D is 1D is 1, 2D is 2, 3D is 3. Okay, so simply I can write in general relation. The general relation, what I can write, if this is g omega, okay, so I can, for d dimensional space, I can simply write this will be d upon s minus 1. Okay, and similarly now I know g omega, so by knowing the relation between energy, okay, so for d space I can simply write my energy, total energy temperature T is proportional to what? T power d by s. What should I write? What should I write? You see the beginning relations. Total energy is proportional to what? When it was omega square, it was T4. When it was omega, it was T cube. When it was 0, it was T square. Okay, so now it will be what? 2 more than this one. 2 more than this one means d plus s1. And in d dimension, okay, your specific heat will be proportional to what? When you differentiate u, you get a specific heat, so it will be 1 less than this one,
Yes.
d by s. Okay, so now you can check it. If you have s equal to 3 dimension, you s equal to 1, this become t cube. For 2 dimensions become t square. For 1 dimension it will become t cv when s is equal to 1. Now if a general s is there, any s is there, that will change. Okay, so based on this we'll do some problems, okay, which came in your exam. Direct using this formula, no need to solve, you can simply put the values, okay, and you can solve it. Are you getting what I'm doing here?
Yes, sir.
Okay. Now one question came, okay, in NAT JRF 2000 December 2011. So he says the excitation of a 3-dimensional solid are bosonic in nature with their frequency omega and k wave number are related by omega equal to k square. This is giving k omega relation k square given, okay, in the large wavelength limit. So we are always using large wavelength only. Low temperature, large wavelength means what? For low temperature only we are using this one. Okay.
Sir, can you repeat the question once more?
The excitation of three-dimensional solid. So this is 3D solid. A 3D solid is given. The excitation of a three-dimensional solid are bosonic in nature, with their frequency omega and wave number k are related by this relation. Okay. If the chemical potential is zero, okay, chemical potential is zero, the behavior of the specific heat of system at low temperature is proportional to. So you're asking at CV, okay, what is the how CV depends on temperature at low temperature. Okay, tell me the answer. So I'm writing options. So options A is T power half, B is T, C is T power 3/2, and D is T cube.
Let's see.
Okay, what should be answer?
Let's see.
C. Okay, how the formula is what for some formula for CB is what? CB is proportional to T power D by S. Now here 3D solid, so D is given 3 and S is given 2. Okay, so CB becomes simply T power 3/2. Okay, now there is one more question on Debye frequency. So everything will change. Okay, what I'm calculating Debye frequency, those everything, the procedure we know how to calculate. Okay, if we know density state, then any dispersion relation given to us, we can solve it for the other values. Okay, so this is so let us solve a few more problems. Just give me 1 minute. Okay. Now we are given the well-known dispersion relation, which we are using for quite a time. Okay, so they're given m omega square 2 beta. Okay, 3 minus cos kxa minus cos kya minus cos kza. The relation they given, they are asking calculate. Okay, calculate density of state in long wavelength region. Okay, so they're asking you have to calculate the density of state at long wavelength region. Okay, and this is 3D solid because x y z is given, so this is obviously 3D solid. Okay, so how can we calculate?
Long wavelength region है kx ky kz सब छोटे होंगे expand कर सकते हैं टाइलर सीरीज में.
Okay, so you want density of states. Okay, so obviously you have the expression for density of state. You know what is the expression for density of state. Okay, and then what? Then you only don't know the omega k relations. Okay, so what you first they are asking what is g omega. Okay, so you know already gk relation for 3D, only you don't know how to convert in omega. So for that they have given this relation. Okay, so the long wavelength region you can expand this one. Okay, so long wavelength means when k tends to 0, you can write cos kxa equals to what? 1 minus kx square a square by 2. Okay, so you can solve it. Similarly, you can write cos kya equals to 1 minus k y square a square by 2 cos kza 1 minus kz square a square by 2. Okay, so when you put these values, okay, you'll get omega square equal to 2 beta m. Okay, and this will give you 3 minus 3 minus, okay, so plus k square a square, okay, and this cancel, so you having 2 beta
फिर अपॉन
and
2 आएगा ना,
k
अपॉन
square
2 कैंसिल हो जाएगा,
अपन 2 आएगा ना, अच्छा
Yes,
2
sir.
भी आएगा,
अपॉन
तो 2 आएगा तो 2 से 2 कैंसिल हो जाएगा, ओके, सो यू विल हैविंग ओमेगा इज इक्वल टू,
और माइनस के स्क्वायर भी आएगा ना,
माइनस तो क्यों, यहाँ माइनस का प्लस हो जाएगा ना,
नहीं सब माइनस हम कॉमन, ओके हाँ सही है सर, सॉरी।
ठीक है, सो ओमेगा विल बी व्हाट, बीटा अपॉन एम, ओके, के ए, ओके, तो हमने पहले भी किया है ए स्क्वायर के, ओके, now you have omega k relation, you have density of states, okay, density of state is in 3D is what, v upon 2 pi square k square dk, and you can write, you want d omega dk value, so d omega will be what, this one beta a square m upon dk, okay, and k value you can get here, so you will get v upon 2 pi square, k square value will become m upon beta a square, okay, okay, this one, and you want dk also, so dk will be d omega upon under root m under root beta a square, okay, so this will give you what, g omega,
देख ओमेगा भी है,
कहाँ पे ओमेगा,
एक ही
हाँ
वैल्यू
हाँ 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 हाँ, एक k की वैल्यू पुट कर दो ओमेगा स्क्वायर पे आएगा, तो here k omega square, okay, so g will come v upon 2 pi square, okay, so ये तो कैंसिल हो जाएगा, तो you will get what, under root m upon beta a square, okay, omega square d omega, let me check, m upon beta square में कुछ मिस्टेक हुआ है क्या, चेक करो,
सर मेरा एक्सप्रेशन तो अलग आ रहा है,
नहीं कुछ मिस्टेक हुआ है, 3/2 आएगा ना, 3/2 आएगा, कुछ एक्सप्रेशन में कुछ मिस्टेक आया है, I am writing the final expression, you just check it what is the mistake, okay, so the final expression is g omega, okay, and 3D solid, if you calculate that, this is the multiply by 3 also, okay, so 3v 2 pi square, okay, m capital M or small m whatever beta a square power 3/2 omega square, ये आना चाहिए आंसर, चेक करो, मैंने रिवर्स करते समय कुछ मिस्टेक किया है,
सर आ रहा है सर,
बाकी लोग भी चेक कर लो,
यस सर आ रहा है।
ओके, now next question which came in 2016, June 2016, okay, you're asking, suppose the frequency of a photon in a one-dimensional chain of atom is proportional to wave vector, okay, you are given 1D chain is given of atom and it says omega is proportional to k, okay, one-dimensional chain of atom is proportional to the wave vector, okay, frequency, if n is the number of density of atom, okay, if n is the number of density of atom, n is the number of density of, so number of density they are given, number of density, okay, number of density they are given is n, which is equal to what, they are total, suppose n atom, so this is one dimension, so this will be n by l, So n by L equal to small n is given. Okay. And c is the speed of phonon. So if you solve this one, omega should be ck, the speed of phonon. Okay, speed of phonon. Then the Debye frequency is asking what is the value for Debye frequency. Okay, Debye frequency. Okay. Now it is very easy question. You know 1D. Okay. So I want, because इसमें जो चारों ऑप्शन है आंसर तो आ जाएगा, आंसर तो जो आएगा हमारा सही आएगा, बट इसमें ऑप्शंस में 4 ऑप्शन दे रखे हैं, उसमें कोई भी ऑप्शन सही नहीं है, थोड़ा सा एक फैक्टर 2 का मिस्टेक है. ओके, तो वो इस मिस्टेक को चेक करने के लिए मैं आपको एक चीज बोल रहा हूँ. Here we assume that omega is proportional to k. Okay, instead of omega, if you assume linear frequency is proportional to k, okay, and that is equal to c upon, so you can use this one, omega is equal to c upon 2 pi k. Okay, this relation. Okay, now you have to calculate. Okay, what is coming. Okay, you first you calculate with this relation, and then you can calculate with this relation. Tell me the difference, what difference we are getting. I hope you are getting what I'm saying. Okay, first you calculate only assuming this one. Okay, what is, we forgot this one, we have this one, and you calculate now Debye frequency. Okay, so you know what is Debye frequency, how to calculate Debye frequency. If you want to calculate Debye frequency, we know the formula also in 1D. Okay, if you don't remember the formula, you can simply integrate g omega d omega, and 1D should be equal to n. Okay, and g omega d omega or 1D, we know what is. This is what g omega d omega is L upon pi. Okay, what is the value? D omega upon, what is the value? 1D. gk is what? L upon pi dk.
Yes, sir.
Okay,
V
so
naught.
v naught.
Omega by-
V naught. Okay, or we instead here they are given c instead of v naught. Correct.
Yes, sir.
Now calculate what is coming. Frequency, what frequency is coming? So if you solve this one, L upon pi, okay, c d omega is simply omega. So this will vd equal to n, and vd is coming what equal to n pi c upon L. Okay, so n pi c on small n pi c coming. Okay, correct.
Yes, sir.
So this is the correct, this is the correct answer. Okay, but option, none of option is matching, but this is the correct answer. Okay, so so for that what we can do, okay, here instead of if you assume linear frequency, okay, if I assume linear frequency, this is proportional to linear frequency. Okay, then what will become? Then your, this is ck. Okay, okay, so we know omega is 2 pi nu. Okay, so 2 pi, so 2 pi factor will come here, so omega will come 2 pi ck. Okay, 2 pi ck. If I use omega equal to 2 pi ck, then what will happen? Then how this expression will change? Calculate the so now I'm using omega equal to ck. I use omega equal to 2 pi ck, and tell me what is the Debye frequency. Nothing will change. Okay,
तो
What will
C की
change?
जगह डिनोमिनेटर में जो C आया था हमारे एक्सप्रेशन में, वहां पे 2 pi C आ जाएगा.
यहाँ पे डिनोमिनेटर में क्या आएगा? अच्छा 2 पाई सी आएगा, तो 2 पाई से डिवाइड, तो 2 पाई से डिवाइड हो जाएगा ना। सो एनसी बाय, मैं चेक करो इसको। ओके,
मल्टीप्लाइड हो जाएगा।
यहाँ मल्टीपल हो जाएगा।
यस यस यस। तो जैसे जो इंटीग्रल वाला एक्सप्रेशन है जहाँ पे हम लोगों ने डी ओमेगा बाई सी लिखा है, वहाँ फिर डी ओमेगा बाई 2 पाई सी हो जाएगा।
यहाँ पे 2 पाई आ जाएगा, विद मल्टीपल हो जाएगा ना।
यस सर।
Okay, okay. Leave it. Okay. Then this is the correct answer. This is the correct answer. Okay. Leave it at one. ये correct answer है. Okay. So let me solve some more problem.
So in both the classes, we'll be solving problems.
Yes.
So in both the classes, we'll be solving problems.
No, no. Next class we'll do some theory also. Okay. So now we have one JEST problem. Okay. JEST, it came in 2012. JEST 2012. Okay. So you're asking the Dulong-Petit law fails near room temperature. Okay. Dulong-Petit law fails near room temperature for many light atoms such as boron and beryllium because of their Debye temperature is. Okay. So he says we have an element boron and beryllium. Okay. For these metals, Dulong-Petit law. What is Dulong-Petit law? What is Dulong-Petit law? That is equal to 3R, specific equal to 3R. That does not satisfy for these atoms at 300 Kelvin. Okay. So what is the possible reason? 1A, that Debye temperature is greater than 300 Kelvin. B, that is equivalent to 300 Kelvin. Okay. C, less than 300 Kelvin. D, 0 Kelvin. Okay. What should be the answer? These metals does not satisfy Dulong-Petit law at this temperature. Why?
क्योंकि इनका CD ज़्यादा बड़ा होगा, क्योंकि सैचुरेशन का ज़्यादा बड़ा होगा।
See, Dulong-Petit, in order to satisfy Dulong-Petit law, what you need? Your temperature should be greater than, your Debye temperature should be what?
Greater than Debye temperature.
So that means this 300 should be what? Greater than Debye temperature.
Yes, sir.
Okay, the 300 should be greater than Debye temperature, but here only they are given 300. That means your Debye temperature is not less than this one. If it is less than this one, your Debye temperature, automatically this become higher temperature for these metals. Okay, see, this Debye temperature decides if your theta d is less than your temperature, less than temperature, then this temperature is a higher temperature. Okay, similarly theta d is greater than T, then this temperature is a lower temperature. Okay, so so this is high temperature. So here Dulong-Petit law will be satisfied. Okay, so now they given if my Dulong-Petit law, if my theta d is less than 300 Kelvin, then this should not satisfied, but not satisfying. That means what? That means my theta d is what? Greater than this one. So that means this temperature is low temperature now. This is high temperature. So here it will not follow Dulong-Petit law. Instead it will follow what? Your T cube law. I hope you got the point. What I'm saying. Dulong-Petit law will be satisfied only when my temperature should be what? Greater than my Debye temperature. Okay. So it is not satisfying here. Okay, that means this option is wrong. So only this option is correct. If this expression is satisfying, then if theta d, if my this temperature is higher than theta d, then automatically it should follow. It's not following. Okay, so that means for these metals, the theta d is higher than, greater than. If you take silver, okay, so silver or silver and gold, or not gold, on silver, you can see this condition will satisfy. So at room temperature itself, you'll get the Dulong-Pettit law. At room temperature itself, you'll get 3R value for silver. And same thing, if you take diamond, you'll get 3R value around 2000 kelvins. Okay, so that is difference between that Debye temperature. Okay, the limit will defined by your Debye temperature. I hope you got the point. Okay, is it clear to you or not?
Yes, sir.
Okay.
Sir, in Dulong-Pettit law, device temperature is less than.
The temperature what is given, okay, if it should be greater than your Debye temperature, then only Dulong-Pettit law will satisfy it.
Okay.
Okay, like silver, suppose my temperature is 200 theta d, so 300 it's greater than 300, room temperature is greater than 200 Kelvin, so my silver will show Dulong-Pettit law at room temperature itself. Okay, now suppose my Debye temperature is 500, so now 300 is less than 500 na?
Yes,
So it will not show Dulong-Pettit law, it will show T-cube law. Okay,
yes, sir.
okay, that's the
Thank
point.
you, sir.
Now one more question is there. Okay, I'm not starting new chapter today, okay, because this chapter is finished. Free electron theory will start from next class. Okay, now he says consider two crystalline solids, one of which has a simple cubic structure. So we have two solids, one has a simple cubic structure and other has a tetragonal structure. Okay, now you're asking the effective spring constant between atoms in the C direction is half of the effective spring constant between the atoms in the A and B direction. Okay, yes, it's a nonsense information. Now he's saying at low temperature, the behavior of the lattice contribution to specific heat will be depend as a function of temperature S. Okay, so two solids are given. One has a simple cubic system and another has a tetragonal structure, and they are giving you two options. Okay, so T square for the tetragonal, okay, T square for the tetragonal, but TQ for simple, but TQ for simple cubic system. Okay, B is T for tetragonal, but TQ for the simple cubic. Okay, C is T for both solids. I'll explain the questions. Okay, and D is given you as TQ for both solids, TQ for both solids. Okay, so you have two solids, one is a simple cubic structure and another is a tetragonal structure. So you're asking 3D solids. Okay, so how their specific should vary at low temperature. Okay, so we know the specific heat do not depend on their crystal structure. Okay, is it depend on crystal structure? No, no. So it do not depend on the crystal structure. Okay, so that means at low temperature both should have a same. So D is the correct option. Okay, okay, और भी बाकी क्वेश्चन बचे हुए तुम करके देखना उसको, आसान क्वेश्चन है सारे. Okay, you check it and solve it. If you found any difficulty in any question, let me know. Okay, now let me solve one more problem now. So when we're doing lattice vibration, okay, that time we have taken example of diatomic crystal, okay. So we have a chain, 1D chain or diatomic crystal, okay. It's A and this is B, okay. And this is infinite chain, or say number atoms n, okay. Now the difference between the case what we have studied and this is there, okay. Now it's saying if you have an atom A and B, both have a same mass, okay. So their mass is same, all atoms mass is same, okay. Earlier one was small, one mass was lighter, other was heavier. Now both the masses are same. Now what it's varying, it's saying that these spring constant, okay. So the right of A is spring constant C1 and left of A is spring constant C1, okay. So this is my C2 spring constant touch chain. Now this C1, say this is C2, or now this is C1, okay. Now for this condition, you have to find out the dispersion relation, okay. I think have you got my question? Now you have a chain, atoms mass as atoms are same, okay, mass is same. Only earlier was spring was different, spring was same, spring constant beta. Now this saying the spring constants are different, okay. So methodology is same. Say now this atom is UN, okay. Say this atom is UN, displacement UN, okay. Say this atom, okay. So this atom displacement is now Vn, okay. I have to make one more atom here, okay. So this A atom, and say this atoms, because this, I'm mentioning A by UN and B by Vn. Their displacement I'm mentioning by UN Vn. You can do what we done earlier, okay. The way I done earlier, you can use that same method also. You get same answer, okay. Now I'm mentioning the amplitude of A as UN, B by Vn. So this is A. So this will be UN plus 1. Okay. So this is Vn. So this will be what? V n minus 1. Okay. Now I want to write the force equation. Okay. So force equation. Okay, for UN. The force on UN. So I know force on UN is m d2 UN upon dt square. Okay. So tell me what is the expression of force on this one. So I told you, if you want to write the expression for this force, first you write the potential energy. Okay. So what is the potential energy of the system? First you tell me what is the potential energy of the system.
1/2.
So if I write potential energy of the system, U, okay, say V or U, let me U, okay, don't confuse by UN. So this will be what? This potential energy Vn, okay, half C2, this spring constant C2 half kx square. X is what? Vn minus Un. Vn minus Un square, okay. And for this one, okay, half C1 Un minus Vn minus 1 square, isn't it?
Yes, sir.
Okay. Now you want to find force on Un. Force on UN, that will be what? Minus d2 du upon what should I write? Dun. Okay. And if you solve this one, you'll get what? C2 Vn minus Un, 2 cancel. Okay. So this becomes 0. So minus plus. Okay. And this become what? 2 minus will come minus 2 C1 Un minus Vn minus 1. Okay. And this 0. Okay. So you can write C2 Vn minus Un plus C1 Vn minus 1 minus Un. Okay. So this is my force on Un. So now same line, you can write force on Vn also. Okay. Are you comfortable with this expression? Students?
Yes, sir.
Okay. So this is force on Un. Now on same line, you can write force on Vn. Okay. So if you write the force on Vn, force on Vn. Okay. What should I write? Force on Vn. Now this one constant will be C1. Okay. This will be C1 and this Un plus 1 minus Vn. Okay. Then plus this C2. Okay. What should I write? Vn minus 1. For this Vn minus is this one. Un minus Vn. This is the expressions for force. Okay, let me check. So and this is equal to what? This is equal to m d2 un upon dt square. This is also m d2 vn upon dt square. So this is your vn minus un plus c1 un minus 1 minus un minus 1. Sorry. Un minus v. Please check. Please check this one whether it's correct or not. C1 is your what? C1 is your Vn minus Un. Okay. ठीक है. So here check it. What is the mistake?
Sir, UN plus 1, no? C1 into.
Which was this one?
No. Yes, sir.
हाँ UN plus 1. ठीक है. Correct. UN plus 1 minus Vn.
Vn.
Okay. ठीक है. Then C2 Un minus Vn. This is correct. Okay. This one Vn minus Un is correct plus C1 Vn minus Un correct. Both are correct. Okay. Now you have done this several times. Okay. Now just you have to put the values of Un Vn and solve for your dispersion relation. So I am giving you the traveling type of solutions. Okay. So Un is what? A iota k Na minus omega t, and I'm giving Vn also b e power iota k Na minus omega t. Okay. You need Un plus 1 also. So Un plus 1 will be a iota k n plus 1 a minus omega t. Okay. And what you need? Un plus, you need Vn minus 1. So Vn minus 1 will be b e power iota k n minus 1 a minus omega t. Okay. Now you have the equation, you have the solution. Put the values and let me know the answer. Okay. So I'm writing answer here. You tell me whether you are getting this answer or not. First, note down this value. So I'm writing answer here. Okay. So answer should come m omega plus minus square c1 plus c2. Okay. Plus minus c1 square c2 square plus 2 c1 c2 cos ka power half. This should come. Solve it.
सर आपका आवाज नहीं आ रहा है।
So I have u and this one. Okay, so I have to differentiate 2 times. Okay, so I'll get, if I differentiate 2 times, this will become AMA. This expression will come as it is, K NA minus omega t. Okay, so since I'm doing 2 times, so I'll get iota minus iota omega minus iota omega square. Okay, this equation. Okay, similarly, if you do C2 Vn, so Vn is nothing, Vn is b e power, so e power iota common, so this become b minus a e power iota k na minus omega t. Okay, and this become plus c1. Okay, so c1, this b should come b, and this become minus iota ka minus 1, and this should come as a, sorry, a should come a, and iota power kna minus omega t. Okay, so if I solve this one further, okay, so this become me, this give me plus iota square minus, so minus omega square m a. Okay, omega square ma, this term will cancel. Okay, so I will be having c2b minus c2a, okay, plus c1b e power minus iota ka, and this is minus c1a. Okay, now let it me write this one. So minus omega square ma, and here is minus c2 c1. Okay, this become plus, so this becomes c1 plus c2. Okay, minus omega square m, this become my a. Okay, and these are plus. Okay, so here it will go minus, so minus c2 plus c1 e power minus iota ka b. Okay, this will be the equations here. This is equation 1. Are you getting this equation? First equation.
Yes, sir.
Okay, so now get write the second equation. The first equation, let me check. Mistake should not be there. So c1 plus c2 omega square a minus c2 plus c1 minus b equals to 0. Okay, correct. Now similarly for vn, we have, this is b. Okay, and this expression will be same. Instead of a, it will be b here. Okay, and here it will change. So here we have, for vn, we are having c1, okay, un plus 1. So I will be having a plus iota ka, okay, minus vn. Minus vn means I will be having b, and then we have a c2 un. Un means a, and vn means b. So if I solve this term is, I will cancel. Okay, so it will come now plus iota square minus minus, okay, minus omega square m b equal to this one. Okay, and if I take solve this one, so c1b and c2b, c1 plus c2. Okay, so this should come now c1 plus c2, okay, minus m omega square, what coming here, it will come here now b. Okay, and what coming here, okay, that will come here. So this will come minus c2 plus c1 e power iota k state. Okay, please check whether you're getting on this equation or not. Okay, so this will become c2 minus b, c2 become positive, b constant b, this become minus, so this will go there, minus a common minus c2 plus c1 iota k. Correct. Check it whether you're getting size, if this equation is correct or not. for second fourth equation. You should get this equation. And once you have this expression, you can solve this by matrix method. Okay, so you have C1 plus C2 minus omega square m, and here you have minus C2 plus C1 e power minus iota k. Okay, and here you have minus C2 plus C1 e power iota k. Okay, and here you have plus C1 plus C2 minus omega square m. Okay, this is the four terms. Okay, a b, and this should be equals to your 0. Are you getting these equations?
Yes.
Yes, sir.
Okay, तो बस सॉल्व कर दो. Okay, now it's easy. If you're getting these equations, just multiply these equations, so you'll get C1 plus C2 minus omega square m. Okay, the whole square, and this is minus plus, so minus C2 plus C1 e power minus iota k, C2 C1 iota k 0. Okay, so if I open this one, this will give me what? Omega 4 m omega 4 minus 2 C1 plus C2. Say this is A and this is the B. Okay, so I'm opening square. Okay, and then C1 plus C2 ka whole square, isn't it? This one, and minus this one. If I multiply by this one, this become C2 square. Okay, this becomes C1 C2 e power iota k. If I multiply this one, okay, this give me C1 C2. So C1 C2 e power minus iota k. Okay, and this become C1 square 0. Okay, so I have m omega 4 minus 2 C1 plus C2. Of course, here this will also come 2 C1 to A plus B. So omega square m also will come. Okay, so now I have m omega 4 minus 2 omega square m omega square C1 plus C2 plus C1 plus C2 square. Okay, and if I solve this one, okay, if I take C1 C2 common, so this will become iota k plus minus iota k, which can be written as a 2 cos k. So I have a C1 square, I have a C2 square, and I have 2 C1 C2. This iota k plus minus iota k, this will give you cos k. Okay, are you getting what I'm doing here?
Yes, sir.
Now this is very simple. If you reach up to here, I'm erasing this one. Can I erase this one?
Just to done, sir.
Okay, so now if you know this one, okay, you can simplify it more. Okay, so what will this become? Omega 4 divided by m. Okay, so this will be you having 2 omega square C1 plus C2. Okay, and you have here C1 plus C2, C1 plus C2 whole square by m. Okay, and this is minus this one. So minus m also. So 1 by m, let 1 by m common. 1 by m common. Okay, so this become c1 square plus c2 square plus 2 c1 c2, and inside again we have minus c1 square minus c2 square and minus 2 c1 c2 cos k. ओके, भी इसको मैंने खोल दिया ताकि ये कैंसिल हो जाए c1 c2. ओके, और m2 मैंने डिवाइड किया, ये सब में डिवाइड किया है मैंने. ओके, आई हैव डिवाइडेड दिस m, so this omega 4, this 2 omega square, and this is divided by m, and also this is divided by m. So I have taken 1 by m common, so and open this expression so that we can cancel out terms from here. And if you solve further, this will give you omega 4 minus 2 omega square c1 plus c2 plus 1 by m. Okay, so this term cancel. Okay, you have 2 c1 c2, 2 c1 c2 common. Okay, and you have 1 minus cos ka. Okay, this is the equation. Now solve this one and tell me the answer, whether you're getting what I have written answer or is different than that. So now this is the quadratic equation in omega square. So the root of this equation will be what? Omega plus minus square. What is the root? Minus b upon 2a. So minus b, so 2 omega square. So 2 c1 plus c2. Okay, upon 2a, a is 1, so 2 plus minus b square minus 4ac, b square this one, b is this 2 c1 plus c2, so 4 c1 plus c2 ka square, b square minus 4 ac, a is 1, c is this one, so this become 8 c1 c2 m 1 minus cos ka. Okay, upon 2a, so upon 2, isn't it?
Yes, sir.
So this is my b square. Okay, and this is m was there, m. Okay,
sir, m hoga c1 c2 by m.
okay, m hoga. Okay, so if you solve this one, this will come what? m कहाँ से आएगा यहाँ पे?
सर
ये
वो m
यहाँ m था क्या यहाँ पर?
m ओमेगा स्क्वायर सर, m स्क्वायर ओमेगा 4 होगा.
Yes, m square omega 4. Okay, so here one m should be there, na?
Yes sir.
Oh, yeah, here one m should be there. So good mistake हो गया ना? So minus, so this become now minus b upon 2a. So 2 c1 c2 upon 2a. Now it's okay. B square minus 4ac. So here also m should be there, na? M square should be there. M square or m?
b square minus 4ac, so m square.
M square. And here 4ac. Here what should be there? M or m square?
m.
Oh, mistake हो गया. Let me check again. Let's check it again. So omega 4 minus 2 omega c1 c2 upon m, 2 c1 c2 upon m, 1 minus cos k. Okay, so this is the up to it is correct here. Now if I write omega plus minus square, okay, minus b, so minus b is 2 c1 c2, okay, minus b upon 2a, 2, so 2 c a, okay, and m is also there, okay, and then plus minus b square. So b square is this one. Okay, so this becomes 4 c1 plus c2 square m square. Okay, and minus 4ac, and 2a also should be there. So 2a and minus 4ac, that means 8 c1 c2 m 1 minus cos ka. M square should be there. M square. M square was there. We divided by M square. So here total term was there. So it should be M square. This should be M square now.
Yes, sir.
Okay, I have done some mistake. Okay, now if you solve this one, omega plus square, okay, this will come C1 plus C2m. 2 को अंदर भेज दो, so this will become what? 4. So this becomes simply m take common, so this becomes C1 plus C2 square. Okay, and it becomes 2 C1 C2 cos 2 C1 C2 1 minus cos k. This should be the answer. What we return plus. Now one step we have to solve further. So if we solve this one, okay, I'll get omega square, okay, C1 plus C2m, okay, plus minus 1 by m under root. This is C1 square, C2 square, okay, plus 2 C1 C2, okay, and then we have minus 2 C1 C2 1 minus cos k. Okay, so m I'm writing here, so this become m omega plus minus square C1 plus C2, okay, plus minus, this become, so now what I can do now, 2 C1 C2 cancel. Okay, so if I write here, this becomes C1 square C2 square 2 C1 C2 here and minus 2 C1 C2 here, and this become minus minus plus, so this become 2 C1 C2 cos k. Okay, and that is the answer I given in the beginning. All of you getting this expression?
sir.
Okay, so please remember this very important thing what we are doing here. Okay, so now this is our, when they have changed the spring. Okay, earlier they were changing the mass, now you change the mass or change the spring, both have the same effect, okay, on vibration. So now if you change the spring, now this is the case. Now what they have given, they have given you C1 equal to C and C2 equal to 10C, and they're asking you calculate omega plus minus square, okay, omega plus minus at k tends to 0 and k tends to pi by a. Calculate. You have to calculate both branches, omega minus and omega plus at k tends to 0 and k tends to pi by a. Okay, so first if we solve this one for omega plus, okay, so omega plus at k tends to 0, okay, so this becomes C1 plus C2, so I'm taking plus, this should be plus, and this k tends to 0, this becomes 1, so this becomes C1 plus C2 ka whole square. Okay, so this becomes C1 plus C2, C1 plus C2. Now this become what? 2 C1 plus C2, and this is given 10C and C 11C. Okay, so this become 22C omega square, omega square is 22C m omega square. Okay, so your omega plus will come 22C by m omega plus. Okay, similarly if I calculate m omega plus square at k tends to pi by a, okay, then what will come? This term is C1 plus C2
So C1 minus C2.
plus this become now this become minus, so this becomes C1 minus C2, so C1 minus C2, so this will, you get what, instead of C1 plus C2 you'll get C1 minus C2, C1 minus C2, C1 minus C2. Okay, so if you solve this one, C2 cancel, you get 2 C1 2c1 is 2. So 2c upon m. So omega plus is 2c by m at k is equal to plus minus pi by a. Okay, or k equal to pi a or plus minus pi by a, whatever you want. Okay. Similarly, now you calculate omega minus. If you calculate omega minus at k tends to 0, so omega minus will be what? M omega square c1 plus c2. Here you put minus. You put 0 here, again c1 plus c2 whole square. This will give you c1 plus c2. Okay. So if you solve this one, now this time c1 will cancel, and you what will 0 is it becomes 0. Okay. So this becomes 0. So you have omega minus at k tends to 0, you have 0 value. Are you getting this value?
Yes, sir.
Okay. Now calculate omega minus at k equal to pi by a, and let me know the value. Only 2 or 3 people are replying, but other people are doing or not doing? All of you getting these expressions?
Yes, sir.
Yes, sir.
Okay.
Omega minus will be under root 20c by m.
20c, very good. Okay, so now if you solve for omega c minus, okay, if you get omega minus at k tends to plus minus pi by a, okay, so what you get here m omega square, you get c1 plus c2 minus this become minus c1 minus c2. Okay, so this become now c1 cancel, and this become 2c2, and 2c2 is nothing, 11c. So 20, and correct na? 2c2 20c. So you'll get omega minus under root 20c upon m. Okay, thank you very much. Okay, so these are your answer. Now I'm not telling you to remember this question. Okay, you just go through the procedure. Okay, what we're doing. So if similar kind of questions given in the exam, okay, no need to memorize. If you know the steps how we are solving, you can do it there. Okay, obviously this is very long expression solution, so this type of question they will not give exam, but they may give like some they may give this expression. Okay, or obviously this expression they can give, because that is a standard result now. When we are done for 2 atoms, when they are spin same, so they may ask this is also standard results, and they may ask you to solve some problems based on this one. Okay, so you should go through, you should solve this one. Okay, so I have done a slightly different way this time. Okay, you do it this same question what we have done in earlier method. Okay, where we are taking 2un plus 1. Okay, by using same both answers should be always same, because they are running type of solution. You can try it in that manner also. Okay, or you can try those question by this method. Okay, by writing un vn instead of not giving common un, you can give un vn and try to solve this way. Okay, so answer will come same. So actually I don't want to start it today new chapter, because today, now the next chapter is free electron theory. Okay, so that will I will start from next class. So this portion is now complete. Now we have free electron theory and band theory. 2 chapters are important chapters are remaining. Okay, a lot of questions are asked in exams, so we'll start that from next class. Okay, any question for today's class?
Sir, when we conduct doubt session, sir?
doubt session, you people have not given me the questions, na? I asked you to send me questions on my WhatsApp or Satish WhatsApp. When you give me doubts, then only I can ask. I can arrange a class. No? One question, one doubt came to me. I don't know who, I forgot the name. He asked me, he has a doubt on dispersion relation. Who was that person?
Me, sir, Beulah.
You are only you are there, na? Okay. So shall I arrange class tomorrow for you?
Yes, sir.
Okay. What time? The same time?
Yes, sir.
Okay. So tomorrow same time. Okay. I'm arranging doubt class. Any other students who have doubt, okay, please send me on WhatsApp or me or Satish. Okay. Tomorrow up to tomorrow morning. Okay. So those students, I will solve. I will clear the doubts. Okay.
Thank you, sir.
Thank you, sir.
So I'm leaving this. Okay.